All right, in this lesson, we're going to learn section 6.4. And that's the graphs of sine and cosine. All right, so we're going to learn how to graph the sine and the cosine function. Now, graphing trig functions is pretty straightforward. Out of all the things that we learn to graph, we always focus on key points. When we learned to graph the parabola, we focused on the vertex. When we learned to graph the absolute value function, we learned to graph the vertex first. When we learned to graph the square root function, we talked about where does the square root function begin? What are the key points on the square root? Same thing with the log function, same thing with e to the x. These functions are no different. We're going to focus on the key points. Now, we'll start with the graph of sine, okay? And so we're going to graph y equals sine x. Now, we have to begin by acknowledging that what we're really doing here is we're graphing a function, f of x equals sine x. We're graphing sine on the x and the y axes. This isn't x and y from the unit circle. This is x and y from our coordinate plane, the x-axis being the horizontal axis, the y-axis being the vertical axis. This, right, this is an angle. This is a number. So a trig function, right, a trig function, and that's what we're talking about here, the trig functions. Trig functions have domains and they have ranges, just like every other function. So we have a domain and we have a range. The domain is an angle, right? We plug in 30 degrees or pi over 6, or we plug in 45 degrees, or we plug in pi over 4, or we plug in 225 degrees, or we plug in 3 pi over 4. We're plugging in an angle, and then the sine curve, or the sine function, pardon me, or the cosine function, they turn that into a number. When I ask sine, what do I get if I put in pi over 6? Right? I'm putting an angle here. So the input, or the domain element, those are angles. What comes out, right? What comes out, we all know this triangle, right? We got our 30, 60, 90 triangle. This is pi over 6 right here. That's 1, 2, the square root of 3. So sine of this is opposite over hypotenuse. What comes out is a number. So trig functions change angles into numbers. We put an angle here, a number comes out here. So when we're drawing our trig graphs, right, when we're drawing the graph of sine x, we have to keep in mind that our input, our domain element, is going to be an angle. Our output, or our range element, that's going to be a number, okay? But we don't want to confuse this with the x and the y going around the unit circle. That's not the x that's here, and that's not the y that's here. That's the unit circle approach to trig functions. We're talking about graphing trig functions. Now, when we want to draw the graph of sine, we know that sine, from playing with the unit circle, we know that the sine function is periodic. Sine sine is periodic. Now, by that, we mean it repeats itself over and over and over again. And we've seen that, right? We've seen that when we've drawn a circle and we have pi over 6 right here. We know that the sine of pi over 6, based on what we just did, right? The sine of pi over 6 turns out to be 1/2. So that is 1/2. And that's pi over 6. But that's repeated when I go around again, right? When I circle around pi over 2 plus pi over 6, I get right back to the same point. This is what we mean when we say sine is periodic. It's going to return the same values over and over and over and over again. Remember, we wrap the whole number line around the unit circle. So all the angles are represented on this one circle. Yes, when we go around the circle one time, we go through a span of 2 pi radians, but we can go around the circle as many times as we want. So when we draw the sine curve, that periodic characteristic of sine helps us because the curve, the graph, is going to repeat itself over and over and over again. Our job is to graph one period, right? So we need to graph only one period of our function then just repeat. And that will give us the graph of sine. Now, when we learn new functions, we start by learning their graphs. So the graph of the sine curve has 5 key points. Okay, 5 key points. And when you want to draw the graph of sine, you need to know the location of these 5 key points. The sine curve is very, very structured because we know that the sine function goes around the unit circle through 4 quadrants. So there are going to be 4 parts to the sine curve. So the first thing we do when we draw the graph of sine is we make 4 equal segments on the x-axis. Okay, those represent the 4 quadrants as we pass around the unit circle. And since the distance around the unit circle, right, that arc length and that arc length, this is pi over 2 radians. So that's pi over 2 long. This is pi over 2 radians. So that's pi over 2 long. This is pi over 2 radians. So that's pi over 2 long. And this is also pi over 2 radians. So this is pi over 2 long. Now we label these points. We know where they are. This is pi over 2. This is pi right here. This is 3 pi over 2 right here. And this is 2 pi right here. Now to draw the sine curve, we need these 5 key points. Where does it begin? And then 4 equal segments. Now these are going to change. If we change the period, they're going to change. But we're just graphing sine right now, just sine. We're not changing the period. We're not doing anything fancy. So we have pi over 2, pi over 2, pi over 2, pi over 2 wide. 4 pi over 2's get me to 2 pi, just like around the circle. Now, we know at pi over 2, we know sine is equal to 1. We know that. because right here, sine is equal to the y and sine is equal to 1. We know at pi, sine is equal to 0. We know at 3 pi over 2, sine is equal to negative 1. And we know at 2 pi, sine is equal to 0 again. Just like at 0, sine is 0. These are the 5 points that allow us to draw the graph of sine. No matter what they give us to graph, if it's a sine function, we plot these 5 points, and then we just connect the dots. Now, if you want your sine curve to look a lot like the sine curves drawn in the book, if you want your sine curve to look more correct, when you're drawing the graph, think about when you go through this point right here, having a slope of -1. Think about your graph being with a slope of -1. When you go through this graph, this point on your graph, think about the slope of your curve being 1. Think about it coming through there with a slope of 1. Over here, likewise, think about having a slope of 1. If you do that, then your sine curve is going to look a lot like the sine curves you see in the book and a lot like the sine curves you see online. We'll learn in calculus why these slopes are these. This is the slope. At that point right there, that curve has a slope of -1 at this point. So that's a calculus idea just thrown in to help you draw your sine curve and make it look more like the sine curves you're going to see in the book. Now, that's not the graph of sine. We're going to put an arrow here. And we're going to put an arrow here because sine is periodic. We know that this curve is just going to keep repeating itself. And over here, this curve is going to keep repeating itself. So if we wanted to, right, if we wanted to, we could extend the curve this way. We could come over here and we could go, okay, well, that's -pi/2, and then that's -pi, and then that's -3 pi. And then here we get -1. Here we get back to 0, and here we get back to 1. And then we can draw our curve over here as well. And if you take a look at that graph, we have origin symmetry. Right, that graph has origin symmetry. What does that mean? So, therefore, f of x equals sine x is an odd function. Okay, so sine is odd. Now, we're going to want to add this to our library of functions. We have a lot of functions on our library of functions now. We've been keeping it up to date, and we'll write out everything that needs to go in our little box here just in a second. But this is the graph, right? Whenever we do our library of functions, we start with a graph. This is our graph of sine. Everything I'm going to do for the rest of the year, whenever I draw the graph of sine, I'm going to make these 4 dots. I don't know how far apart they're going to be. They're not always going to be pi/2 apart, but they're always going to be the same distance every single time. How far apart are they going to be? Well, it's going to depend on what the period of our function is. And we'll talk about in a few minutes how to find the period of our function. Okay. So this is our base graph for sine. This is what we have to draw. On the test, we have to draw a graph that has one complete period. One complete period. Anything less than that is going to be considered incorrect. We have to label our maximum, our minimum, and our x-intercepts. Okay, so we would have to label this. This would be pi over 2 comma 1. This would be pi 0. This would be 3 pi over 2 comma negative 1. This would be 2 pi comma 0. And this would be 0, 0. So just like everything else we've graphed, we're going to have to label our points on our curve. Okay, we're going to have to label our points. We don't need the blue slope indicators on there. Again, those were just there for me to give to you to help you draw sine curves that look more like the sine curve you're going to see in the book. They're going to look more correct. Okay, these are not semicircles. We'll learn some interesting things about this curve when we get to a calculus class. All right, we'll learn some things about the curve, but this is not a semicircle. Don't make a semicircle. That I understand that's a semicircle, but that's the unit circle. This is the graph of sine. They're related, right? They're related. We can all see right here. Now, what I'm about to do right now is not part of the graph of sine. It's just an extension to help you understand what's happening and how this relates to this. If somebody asks me to graph sine, this is what I do, what I have right here. So what I'm about to do is just an extension of understanding. But if we just, these are not asymptotes. I'm just making some lines here to help us see what I'm going to talk about. There are no vertical asymptotes in the sine curve. Its domain is all the reals, so it doesn't have any vertical asymptotes. So if we take a look and we just slice the sine curve up into its 4 pieces, right? Its 4 component pieces. This goes from 0 to pi over 2. This is quadrant 1. This goes from pi over 2 to pi. This is actually quadrant 2. This goes from pi to 3 pi over 2. This is actually quadrant 3. And this is actually quadrant 4, 3 pi over 2 to 2 pi. Now take a look at what we said. We said all students take calculus, right? So we said sine was positive in quadrant 1. Look at the graph. It's above the x-axis. That graph is positive. It's above the x-axis. We said sine was positive in quadrant 2. Look at the graph. It's above the x-axis. Sine is positive in quadrant 2. But we said sine was negative in quadrant 3. Well, look at the graph. It's below the x-axis. Sine is negative in quadrant 3. Over here, look at the graph. We said sine was negative in quadrant 4. The graph is below the x-axis. It's negative. Think about it from this perspective. If you start here and start on a journey, you're going up as you go that way, right? You're going up. You're traveling higher and higher and higher. Look at the graph. Over here, you're going down. You're traveling lower and lower and lower. If we were just thinking about this as a hike up a hill, we're going uphill here, downhill here. Look at the graph. We're going downhill. Here, we're still going downhill. If we were taking a hike, we're below the height of where we started, right? If we're taking a hike up a hillside, we're going down here and we're below the elevation from where we started. Look, we're still going down. We're below where we started. Now over here, we start climbing back uphill. Look at the graph. We're going back uphill. The unit circle and the graph are related. They're not the same thing, but they're related. All right. So how do I graph sine? I make my 5 key dots. Where do I begin? Split it into 4 equal parts. Label them correctly. We'll talk about how to find those labels in a second. Put our heights, connect our dots, put an arrow at the end. That's 1 period of sine. Our standard function goes from 0 to 2 pi, has a height of 1, has a lowest point, a local minimum of -1, and has y-intercepts at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, so this is how we graph sine. Now, how do we graph cosine? Well, to be perfectly honest with you, almost exactly the same as we graph sine. I'm going to erase this, get this out of the way. I'm going to leave that unit circle there. And we'll talk about what does the graph of cosine look like. Right? What does the graph of cosine look like? So now we're going to graph y equals cosine x, or in function notation, f of x equals cosine x. Still the same game. Domain is going to be an angle. The range is going to be a number. This is how trig functions work. You plug in an angle and a number comes out. So what does our graph look like? How do we draw the graph of cosine? Well, we duplicate the same steps. We split this into 4 equal parts. We label this one pi over 2. We label this one pi. We label this one 3 pi over 2. We label this one 2 pi. This, of course, is 0. This is going to be one period of the sine curve, cosine curve. One period. Okay. Now, we have to figure out what are our y values. What are our y values? Well, we learned that our y values, those are the numbers, right, that we get when we plug in the angle. Those are the numbers we get when we plug in the angle. Well, when we plug in 0, we get 1. That's what cosine is. So when we plug in 0, we get 1. So that dot's going to be here. When we plug in pi over 2, all right, pi over 2, we get 0. So that dot's going to be here. When we plug in pi, we get -1. So that dot's going to be right here. When we plug in 3 pi over 2, we get 0. So that dot's going to be here. And when we plug in 2 pi, we're right back here at 1. Now, when we draw our cosine curve, it looks like this. This is one period. Now, of course, it keeps going, right? It keeps going. This is one period of our cosine curve. So if we were going to graph cosine, we would label all of these points, 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. It looks very similar to the sine curve, doesn't it? It's because we're going around the same circle. We're going around exactly the same circle. So we're going to get a graph that looks very similar to the sine curve. Now, if we were to continue, right, if we were going to continue this over here, this is going to be -pi over 2 and -pi and -3 pi over 2. This would be 0. This would be -1. This would back up to 0. And our curve would look like this. Now, if we take a look at this, we see that f of x equals cosine x is even, meaning f of x equals cosine x has y-axis symmetry. Okay, y-axis symmetry. So When we draw the graph of cosine, we're going to make 4 points equally spaced. We're going to figure out where we start, and we're going to make our dots, and we're going to connect our dots. Okay, that's how we graph sine and cosine. It always comes down to, what are these 4 points? How far apart are they? Okay, and I'm going to do more examples, and you'll see that as we go through the examples. And we're going to keep in mind that cosine is even. It has y-axis symmetry. Sine is odd. It has origin symmetry. Okay, cosine is even, sine is odd. Cosine is even, sine is odd. And we'll keep that in mind as we draw our graphs. Now, if we put the sine curve on top of this, right? The sine curve started here and went through here, then went through here, was -1 here, and was 0 right there. And then here was -1. Here was 0. Here was +1, right? If we draw the sine curve right on top of the cosine curve, I think you'll notice that there's a relationship between these two graphs, right? There's a relationship between these two graphs. If we were to take the cosine curve, the blue one, right? Just look at the blue graph now. If we were to take the blue graph and slide it over here, pi over 2. If we were to slide it pi over 2, right? What happens if the word we use is shift, right? If we shift y equals cosine x to the right, by pi over 2 units, right? What happens if we slide it to the right, pi over 2? Well, if we slide this blue graph to the right, pi over 2, where does it land? Well, this dot lands right there. This dot lands right there. This dot lands right there. That dot lands right there. If we shift y equals cosine to the right by pi over 2, right? That's our question. Our answer is we get y equals sine x. That's what happens. If we shift, and we know how to move somebody to the right, we know that if we go like this, and we put a minus right there, inside, we know from graphing all of our lives, if you put a minus in there, that shifts to the right. We know that. That's right, left. That's not up and down. That's right, left. If we know, if we want to move right, we put a minus. And if we put a pi over 2 right there, we turn out getting sine. That's the relationship between sine and cosine. They're actually the same thing. Sine is just cosine shifted to the right, pi over 2. And that's going to be something we want to keep in mind. The graphs have exactly the same shape, the same domains, the same range, right? If we take a look at the range, if somebody asked us, what's the range? Well, the maximum is 1, right? So the range, if somebody asked us for the range, the biggest we get is 1. The smallest we ever get is -1. So our range is smaller than 1 and bigger than or equal to -1. That's our range. Our domain, of course, is all reals. Because both these graphs just keep going forever. Now we're ready. We're ready to go fill in our library of functions. We have all the important information. And Mr. Sullivan, he even writes it down for us right here in the book, just like he did when he was teaching us all the other functions back in chapter 3. He's got it all written right there. We can copy this onto our library of functions. The domain is all there is. We've got that in our notes. The range goes from -1 to 1, including the endpoints. We have that in our notes. The sine function is odd. We wrote that in our notes. The sine function is periodic. The period is 2 pi. We wrote that in our notes. The x-intercepts are 0, pi, 2 pi, 3 pi. We showed that on our graph. The maximums and minimums, well, there's a lot of local maxes and local mins, and there's a lot of absolute maxes and absolute mins, right? This is an absolute max and a local max. That's an absolute min and a local min. And they repeat themselves over and over and over and over. So that's our foundational look at the graph of sine and cosine. But we know that they're going to ask us to do more than just graph sine and cosine. If all they were going to ask us to do is just draw the graph of sine x and cosine x, well, then this would be, this would be great. But we know that's not what's going to happen. We know they're going to ask us to do transformations, because that's what always happens when we graph, right? When we learn to graph, the next step after we learn our basic graph is to learn our transformations. So we're going to talk about transformations. Okay. That's where we always end up. Now, the good news is we know transformations. We're very good at up, down, right, left. Right? We're very good at that. We're very good at upside down, right side up. We're very good at that. We're very good about reflecting across the y-axis, right? That's upside down. But we're also very good about reflecting across the x-axis is upside down. We're very good about reflecting across the y-axis. Transformations here are the same old story. Nothing's going to change, right? When I taught you these way back in the back times, chapter 3, chapter 2, I said, this is why we're going to do everything. It hasn't changed. So we get in our book, our author puts this down and he puts this down. Now this is omega, not W, okay? W goes like this and little w goes like this. Omega goes like this. And it curves. It's the Greek letter omega. This is what our author uses. Okay. So he wants us to figure out how are we going to graph sine omega x. That's how we read that. Okay. So he gives us something like y equals sine 2x. What happens if he puts a 2 inside the function? Inside the function, right? This is either going to be a horizontal or a vertical compression or stretch. That's how we talked about it right back in the day. And we know this is horizontal. We know it's horizontal. And horizontal is the one we didn't like, right? That's a 2. We would have said this is a horizontal compression by a factor of 1/2, right? That's what we said back in chapter 3. The horizontal was one we had to fight to remember. We're like, oh, on the inside, it's backwards. So it's a 2, which is a bigger than 1 number But that's not a stretch, that's a compression. That's the cross we had to bear back then. But in trig functions, there's an easier way to do this, okay? In trig functions, we focus on two things: amplitude and period. So what you're going to hear me and your calculus teacher always talk about when we graph trig functions is we're going to talk about amplitude and we're going to talk about period, okay? You're not going to hear us say horizontal compression, horizontal stretch, vertical compression, vertical stretch, because there's an easier way to do it with trig functions. Not because we're trying to make it trickier, because we're trying to make it easier, okay? For us, amplitude is going to be the absolute value of A. Period for sine and cosine, and that's what we're talking about here, sine and cosine. The period is going to be 2 pi divided by omega. This is how we're going to graph. So when somebody gives us a problem, we're going to ask ourselves, and we're going to write down, our teachers are going to expect to see on the paper amplitude, period. They're going to expect to see it written there, and they're going to expect us to fill this in. Amplitude, period. They want us to fill this in. Now, A is right here. Michael doesn't put it down in his book, but I'm going to put it into your notes. That's why I changed the color. Michael doesn't put it in the book. So I put the things in the book in blue, but the part you and I are going to add to make this better, I'm going to put that in red. That's amplitude. Okay, so here's my example. Here's my example. Now I'm going to go ahead and plug the amplitude in. There it is. Okay. So if I were doing this and I was turning this in on a quiz or a test and I wanted full credit, I would write amplitude. I'd put a colon, I'd write absolute value of A, and then I would do the work. Absolute value of 1, my amplitude is 1. Okay, now we have to write that down. Now our period, we're going to write period, colon, 2 pi divided by omega. We're going to write that down. That's required. And then we're going to do the work. 2 pi. Our omega, in our example, is 2. And so our period, 2 divided by 2 is 1. Our period is pi. Now we're set. We're ready to graph sine. 2x. So how do we graph it? The same steps. We go like this. We're going to make 4 hash marks, just like before. 1 hash mark, 2 hash marks, 3 hash marks, 4 hash marks. We're going to make 4 hash marks on this side. Okay. Now, when we were earlier in the video, I told you we're going to have to determine what numbers go on these hash marks. Well, it all comes down to what your period is. Our period is pi. So this is pi. Instead of ending at 2 pi, our period for our graph is 1 pi. So I put a pi in. Now, what I like to do is I like to take this and multiply it by 1/4. All right, I like to add on this extra step. I think it helps. Because sometimes this doesn't turn out to be a very nice number. Now, what does that tell me? That tells me how far apart these are. Look, I got pi over 4 here. Then I do another pi over 4. That's 2 pi over 4. Then I do another one. That's 3 pi over 4. Over here, I'm going to get negative pi over 4. Negative 2 pi over 4. Negative 3 pi over 4. Negative 4 pi over 4. Okay. Now, I understand some of these reduce. Okay, but trust me, I know where we're going here. It's better if you don't reduce them. Don't write that as pi over 2. It's only going to make your life more complicated if you do that. Once you find your basic, what I like to call my basic counting unit, which in this case is pi over 4, I'm going to leave everything in pi over 4. Even this piece over here where My pen decided to spit up all over the whiteboard. So if you don't reduce, this is going to become a lot easier for you. These numbers are going to become sometimes, not every problem, but sometimes they become a little tricky. And if you don't reduce them, it's so much easier. Now, what do? Okay. We ask ourselves, what's our amplitude? Okay, our amplitude is 1. Amplitude tells me how high my sine wave or sine curve is going to be, right? When we see waves, which is what the sine looks like, amplitude is how tall that wave is. That's what the word amplitude means. So our amplitude in this problem is 1. So if we look at our graph, it's going to be 1 high. So I'm going to come over here and I'm going to call this 1, and I'm going to call this -1. Now that's as tall as my sine curve is going to get. Now I have to put my dots down. Okay. We don't move left or right, right? There's no plus or minus inside here. We're not moving left. We're not moving right. We're doing nothing about left or right. So we know we're graphing sine. Sine starts right there. Then at the first dot, it's 1 high. At the second dot, we're back at 0. At the third dot, we're at -1. At the fourth dot, we're back to 0. That happens on every sine curve. If I don't move left or right, I just, now I've got my dots down. Now I just connect them. Put an arrow at the end. Over here, we would be down here, negative. Then we're back to 0. Then we're up here at 1. Then we're back to 0. And we just connect our dots. And we've graphed sine. Now, on a test, we'd have to label these, right? So that's pi over 4, comma 1. That's 2 pi over 4. Trust me, it's easier to stay that way. 0. This is 3 pi over 4, -1. That's 4 pi over 4, +1. And then we would label the other side. Negative pi over 4, -1. -2 pi over 4, 0. -3 pi over 4, +1. -4 pi over 4, 0. That will get you 100% on the test. Our requirements at Bakersfield High School are 1 complete cycle. That's what we call it when it starts at 0 and gets all the way back to 0. 1 complete cycle on the positive side, and 1 complete cycle on the negative side. That is a Bakersfield High School requirement. Doesn't matter whether you're in my class or Mrs. Tedder's class, Mrs. Rainier's class, or Mrs. Lovejoy's class. That is a requirement. 1 full cycle in the positive side, 1 full cycle in the negative side. This is how we graph sine. Okay, again, from the top, what did we do? We found the amplitude, we found the period. We used the formulas. We took our period, we divided it by 4 because we needed 4 equal pieces. It's always going to be 4 equal pieces because sine has 4 equal pieces. Cosine has 4 equal pieces. We put our hash mark, hash mark, hash mark, hash mark. We labeled them in a counting way: 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. -1 pi over 4, -2 pi over 4, -3 pi over 4, -4 pi over 4. We found our amplitude. Our amplitude was 1. We noticed we were not shifting left and right. So we put our dot here because we were doing sine. We started 0, 0 for sine, and then we just connected our dots, and we're done. Okay, so I'll do another one. I'll do another one. So let's do another example, right? We'll do y equals, we'll do cosine. This time we'll do cosine. And we'll put in here 1/2 x. Okay, and I'll put a 2 outside. So the very first thing I would do if I was starting this problem is I would write amplitude, absolute value of A, absolute value of 2, 2. So my graph is going to not be 1 high now, it's going to be 2 high now. So now I have to make sure I keep that in mind. My graph's going to be too high. Then I do my period. I write 2 pi divided by omega. For us, that's 2 pi divided by omega is 1/2. That's 4 pi. Okay, so my period is 4 pi. Now I take that, I multiply it by 1/4. That's my counting unit. Okay, that's my counting unit now. Now, I draw my axes. I'm going to need 4 dots because I know I need 4 pieces to graph cosine. Cosine and sine, and that's all we're doing in this section, cosine and sine. It's always 4 pieces. So I go 1 piece, 2 piece, 3 piece, 4 piece. 1 piece, 2 piece, 3 piece, 4 piece. And I know how big they are. They're going to be pi big. So this is going to be pi, this is going to be 2 pi, this is going to be 3 pi, this is going to be 4 pi. That's my period. 4 of them always equal whatever my period turns out to be. It always matches. These are going to be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. All right? We're doing cosine. Doesn't matter. Works just like sine. The only difference with cosine is we don't start at 0, 0. If you look at your base curve for cosine, your base curve for cosine starts at 0, 1. Right? You wrote it into your library of functions. It starts at 0, 1. But our amplitude is not 1. So our maximum isn't going to be 1. Our maximum is going to be 2. So I'm going to go up here and I'm going to call that 2. I'm going to go down here, I'm going to call that negative 2. Cosine gets a dot there. Then this dot goes at 0. This dot goes below. This dot goes back at 0. This dot goes above. That's our basic cosine graph. Our basic cosine graph, right, looks like this. Put an arrow because it keeps going. And then over here, because cosine's even, y-axis symmetry, it goes through there. It's right here, it's right here, and it's right here. And now we've got our cosine curve. All we have to do is make these 4 hash marks, figure out where we start, put our dots down, and we're done. And then, of course, if this was a test, we would label all these. 0, 2, pi 0, 2 pi negative, negative 2, right? Because our amplitude is 2, almost missed that. 3 pi 0, 4 pi 2, because my amplitude is 2, negative pi 0, negative 2 pi, negative 2, negative 3 pi 0, negative 4 pi 2. And we're done graphing cosine. Now, the only thing other than this that happens in the homework, the only thing other than this that happens in the homework is something you already know how to do. I'll do it here but you're good to go, right? But I'm going to do two more examples. One of them, I'm just going to kind of hodgepodge this example, right? What happens if they put a +1 outside? What does that do to our graph? Right? What does that do to our graph? You're correct. It moves it up 1, right? That's what it would do to our graph. We would move our graph up 1. Now, how do we do that, right? How do we do that? Well, when you're graphing a trig function, you just take all, you graph this first, okay? You have to get this graph down first. And then you just take this dot, you move it up 1. You take that dot, you move it up 1. You take that dot, you move it up 1. You take that dot, you move it up 1. And you take that dot, and that dot, sorry, excuse me, and you move it up 1, and then you redraw your curve. Okay. Now you label these points, right? You know that that is 0, 3. Why is it 3? Well, because we went up 1. This is going to go up 1. So that's going to be pi 1. This is going to go up 1, right? So that's going to be 2 pi negative 1. This is going to go up 1. So that's going to be 3 pi 1. Because we went up 1. This goes up 1. So that's going to be 4 pi 3. That's how we move up and down. We move our key points, right? We move our key points. Our key points. We move our key points. Now, make sure you write this in your notes. We're not going to be able to find those x-intercepts, okay? No one's going to ask us for those x-intercepts. We can't find those x-intercepts. I mean, we can, we can use our calculator, but we're not going to know when we move the graph up and down, those x-intercepts change to really ugly numbers, numbers we're not going to want to worry about. Okay. All right. So when we graph sine and cosine, it's always about the 4 intervals. It's always about the 4 intervals. And then if we do these two calculations, which are required, then we can then draw the graph, right? I'll do another example, and I'll make it really ugly, right? I'll make it uglier than anything in the book. That what I'm about to do is not in Michael's book, okay? It's not in his book. He doesn't have anything in the homework that's this ugly. I'll make this 4/7 y equals, 4/7 sine, and then we'll make this 2/5 x, like that. All right. Now, I'm going to tell you right now, there's nothing in the book this bad. But the thing that you're going to come to realize pretty quickly when you graph sine and cosine is there isn't really a bad. No matter how ugly the numbers become, there's not really a bad. Because you go like this. You go, okay, what's my amplitude? Absolute value of A, right? You write that every time. That's going to be the absolute value. I'll tell you what, we'll even make this -4/7. We'll make the graph upside down, right? So we're going to go -4/7. So my amplitude is 4/7. Okay. So what's my period? Oh my goodness. What's the period going to be? Well, it's 2 pi divided by omega. That's going to be 2 pi. Omega is 2/5. Now that's going to take some arithmetic, right? That's 2 pi over 1 times we 5/2. Okay, so I didn't want the 2 to cancel. I didn't want the 2 to cancel. So I'm going to go back here and I'm going to change this example. I'm going to make that a 3 because that ended up being way too nice. I was trying to make it ugly, so let's make it ugly. There we go. Now it's really bad. Okay, now it's really bad. Now we can all do that math. That's 10 pi over, what's going on? All the pins are blowing up today. I'm not really sure what's happening with my pins. Maybe the world's ending and I just don't know it. So that's 10 pi divided by 3. Oh my gosh, right? So those are not good numbers. I mean, we got 4 divided by 7. We got 10 divided by 3. And we're upside down. Okay, now what do we do next? We take this and we multiply by 1/4, right? That's what I told you. That's going to be 10 pi over 12, right? Isn't that what I said? Multiply by 1/4. Why did I do that? So I can get my counting units, right? I need my counting units. Now, what do we do from here? We draw our x-axis. There's no reason to hyperventilate. We just draw our x-axis. Now, I told you, count by these. Okay. Now you can reduce that, right? We can reduce that. That's 5 pi over 6, isn't it? 5 pi over 6. So we need 4 dots. 1, 2, 3, 4. The first one's 5 pi over 6. The next one's 2 of those. That's 10 pi over 6. The next one's 3 of those. 15 pi over 6. The next one's 4 of those. 20 pi over 6. We're supposed to be at 10 pi over 3, right? That's where we're supposed to stop. 10, that's where we stop. That's our period. We stop. And we certainly do. Look, 20 pi over 6, 10 pi over 3. We make 4 dots on this side. Nobody cares how bad these numbers are. We go negative 5 pi over 6, negative 10 pi over 6, negative 15 pi over 6, negative 20 pi over 6. Right? It doesn't matter. Once you know this trick right here, you can just do your countings. Remember what I told you. Don't reduce them. It makes it harder if you reduce them. We have more things to graph coming up. I know where we're going. Don't reduce those. Now, what are we graphing? Sine. Sine starts at 0, 0. So we put that first dot down. Now we're upside down. So, whoa, we got to put a dash. Right? Now, what's our amplitude? 4 over 7. Okay, so all you do is write 4 over 7. Now, instead of going up, down, down, up, right? Our sine's upside down. So now we're here. Then we go back to here. Then we go up to here. Then we go down to here. And then we draw a sine curve. And nobody cares how messy the numbers are. See, messy numbers don't mess you up when you do trig. You just make 4 hash marks, equal distance apart, label them all by counting. Pick whatever your amplitude is. Nobody cares that it's an ugly number. Just put a dash mark, a dash, call it 4/7. Okay, 4/7. Now over here, right, we're doing sine, so we have origin symmetry. So we're up there, we're down here, we're down here, we're up here. Arrow, arrow, done. We would have to label our points to get credit on the test. That's how we graph sines and cosines. That's what we do. So what are our important tricks? What are important things to remember? Okay, we have to write down the amplitude. We can all find that. It's an absolute value. We don't even do any math other than the absolute value. The period, we have to remember for sine and cosine, right? Sine and cosine. The period is 2 pi divided by omega. Now notice I keep saying sine and cosine. It's not the same for tangent. But for sine and cosine, it's 2 pi divided by omega. So we do that math. We can all divide fractions. We learned how to do that in elementary school. We get our period. Oh, that's not a very good number. I agree, that's not a very good number. That's okay. We multiply it by a fourth. It gives me 10 pi over 12. Okay, not a good number. I agree, not a good number. So I simplify, right? 5 pi over 6. I go one of those, two of those, three of those, four of those. 4 equal pieces. One of those, two of those, three of those, four of those. One on each side. 4 pieces on that side, 4 pieces on this side. Sine starts at 0, 0. Okay, I put a dot there, and then instead of going up, because I have a minus, I go down. Then I go back to 0, then I'm up, then I'm down, connect my dots, I'm done. I'm done. And if somebody has the audacity to ask me to graph this, I would do all those steps exactly the same. All of them. All the steps are the same. I would still make the 4 hash marks. Cosine gets 4 hash marks. Everything is the same, except I would go, oh, well, cosine doesn't start at 0, 0. Cosine starts right there. But ours is upside down. So I'm going to start right here. Then I'm going to go to 0. And I'm going to go to 4/7. Then I'm going to go to 0. And then I'm going to go to minus 4/7. And then I would draw this. And I'd have the graph of cosine. When some student says to you, if you talk to a friend and they say, oh, I hate graphing tangent and cotangent, I hate graphing sine and cosine. You know what that means? They didn't do the homework. That's what that means. Because every problem is exactly the same. Okay. Now, remember, you have to do the homework by Monday night at midnight. It's due Monday at midnight, Monday. When I see you Tuesday and when I see you Wednesday, you're going to be done with the homework from this section. When we meet next week, I am teaching you section 6.5. So you have to do this on your own, right? Now, what's our homework assignment? Well, you're going to get kind of bored with it because you're kind of graphing the same functions over and 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 over again, right? So our homework is 6.4, number 11 through 67 odd, right? 11 through 67 odd. Now this is due, right? This is due at 11:59 p.m. Okay, 11:59 p.m. All right, 11:59 p.m. All right. Everybody have a great time. Enjoy section 6.4. And when I see you, I'm teaching you section 6.5. All right. See you.